sketching trig functions, and this time we will be looking at examples and we will be using radians. So for each sketch or transformation of the trig functions, we're going to need to collect this information: the period, the amplitude, the equation of axes, the maximum and the minimum value. Now what's key about this and the difference with when we do examples, when we use degrees, is that when we use radians, the formula for the period is 2 pi over k. So that's what we're going to be using now. And of course each of the questions will have this format. Okay, let's take a look at our first example, and it's y equals 5 cosine open bracket 2 open bracket again x minus pi over 2 close the bracket, close the square bracket, plus 1. In any case, I don't know why I read that whole thing. So first, what's the base function for this? Well, let's start with that. The base function, it will be y equals cosine x. So let's sketch that here on the side so that we know how it looks like. We should know this by heart. And then, so it starts at the top, it goes down and it ends here. And it takes 2 pi to complete one cycle. Halfway between that will be pi. Halfway between these two would be pi over 2. And over here would be 3 pi over 2. Okay, so that's our base function. Now let's collect all of the other information. We have A as the amplitude, so that's equal to 5. The equation of axes will be y equals to 1, right? The value of k is 2. Actually, before we look at that, which is going to help, that too is going to help us to find the period. Let's take a look at this value, the value of d. The value of d is equal to, well, there's a shift to the right by pi over 2 units, so therefore d equals to pi over 2. And we need to find the period. Now we know that the period is equal to 2 pi over k. The value of k here happens to be 2, so our answer will be, fine, let's put it here. P equals 2 pi over 2, which means our period will be equal to pi. Okay, so I think we've got everything. Well, actually not quite. Let's find out the maximum and the minimum value. So the maximum value is equal to c plus absolute value of a. Okay, let me make some space here. Equals, let me move this up now. What's the value of c? 1 plus a, that's 6. And the minimum value would be c minus absolute value of a, which is 1 minus 5, which gives us minus 4. Okay, so I think we've got everything now. This is the period, by the way. The period is equal to pi, and now we've got everything that we need to sketch this function. So let's begin with the value of d, where we're going to start graphing the function. So just like the previous examples, if you haven't seen the ones that we did with by using degrees, I encourage you to check them out, but they're very similar. It's just that now we're using radians. So this will be our pi over 2. That's where we start. And then our equation of axes, let's put it right there, right? The main thing, the main goal for this is that you show the key points, right? Now the maximum value here is 6, and the minimum value will be -4. Okay, and so we start, so the base function, we know it's going to be y equals cosine x, and so we start at the top, we start at the maximum value, and then we go down, and then we return to the maximum value. So similarly here, now if we start at pi over 2 and the period is equal to pi, then we're going to end up where? Well, we're going to end up at 3 pi over 2. And if it's not, sometimes it's hard to picture it, I like to do this. So just quickly make, you can quickly make a unit circle like this. Look, 0, pi over 2, pi, 3 pi over 2, and then one complete cycle 2 pi. Now we're starting here at pi over 2, and the period is pi, so from here to here will be pi, so we end up at 3 pi over 2. I don't know if you guys can see that. Yeah, and it's right there at the corner, but there it is, okay? So that means if we start here at the top, we're going to end up at here, which is going to be our 3 pi over 2, all right? Now halfway between these 2 points will be pi, and halfway between these two will be pi. So halfway is pi, and then halfway between these two is something, and halfway between those two is something that I don't recall quite yet. Actually, no, let's figure it out right now. So between these two, pi over 2 and pi, we're going to have that value. So that means we need to add pi over 4. So what's pi over 2 plus pi over 4? Well, that will give us, let me make the calculations here, you know. Pi over 2 plus pi over 4. Well, that's going to give us basically, this is like saying 2 pi over 4 plus pi over 4. So that's 3 pi over 4. Okay, so over here we have 3 pi over 4. And what about here? Plus another pi over 4. That's gonna give us a 5 pi over 4, if I'm not mistaken. 5 pi over 4. And if we're not sure, basically we're landing there, basically, right? That will be our 5 pi over 4, and this will be our 3 pi over 4. Okay, so I think we've got everything. So now let's just plot the points. You start at the top, you end there, you end there, you end there. So you hit the bottom, and then we start moving up again, and then we end right here at the maximum value. So now let's join these with a smooth curve. So right, join them with a smooth curve. And that's it. That's our sketch. Now, I guess we could draw the x-axis, but that's going to be off the screen, so somewhere over there. What about this value? So it would be what? 1/5 of the way down. So that's like 1, 2, 3, 4, 5, more or less there. So more or less, I would say, if you really want to draw the x-axis, it will be there, and the y-axis will be somewhere over here. But that's our sketch. You are showing me the max, the min, the equation of axes, and the key points. The key points, like this, right? You label it, each one of them. So that's it. That's our first example. Let's take a look at a few more.